Good morning. In this presentation we will see the functioning of ESApro P&ID and ESApro instrumentation, the ESApro modules for the design of the process schemes and the datasheet creation. ESApro P&ID is a simple AutoCAD application. So, beside the standard AutoCAD interface, we have a customized menu with the application commands. Now, let's open a process scheme. And we see that it is made of normal AutoCAD entities, a block and a line. Double-clicking on the block shows the ESApro properties, like diameter, material and valve tag. And if I double-click on the line, I see the properties: number, fluid class, nominal diameter, pressures and temperatures. Let's now take a look at the database. Select Spec Management and Symbols. In this table, we have a list of all graphic symbols that are provided by the software. Each graphic symbol is a block with 5 description languages and different possible representations. The blocks are all customizable according to the user's needs. In Class Management, we have a list with all the piping classes we can use to draw our process lines. Here we have a set of components and a sample class. Besides the pipe, we have the valves, gate, ball or check valves. According to the diameter, we have different types. Sometimes they are flanged and other times threaded. Now, let's create the new piping class named W001. Enter a description and add our components. Double-click, and we will begin with the pipe, and here we specify the diameters to use. We enter the minimum diameter, 50 mm ½ inch, and the maximum diameter, 200 mm 8 inches. Outside this range of diameters, it will not be possible to draw lines. Let's insert our gate valve, which use a range of diameters from 800 to 200 mm. We give a tag prefix. This is the name that will be assigned to the valve during the insertion. And these are the technical characteristics: standard, rating, 150 pounds, so we use ASME standard. And the end type, in this case flanged RF. Now we choose the graphical representation for the symbol. Confirm the insertion of the component, and we add another valve, a check valve. Also, this valve is flanged and has the same characteristics, only the tagging prefix changes. For smaller diameter ranges, we select another check valve, but with another end type. We choose the TH end type, which is the threaded one. Still missing a valve for small diameters, we can choose a ball that is tagged as BL. Therefore, they will be numbered as BL01, BL02, BL03, etc. We start by inserting a vessel. Pick the graphic block, position it in the drawing, and assign the tag TK001. On the other fields, we can add other information, manufacturer, model. And we can paste information directly from an Excel sheet that we've previously loaded into the project, so we can easily manage standard equipment. Resize the symbol using grips. And let's insert a table showing the tank data. The data tables show all the technical characteristics of the equipment. They are standard AutoCAD tables that can be placed at any position, and which are, of course, updated every time we go to modify the equipment data. Now we're ready to create a new line. In the line dialog, we can type a new line number or select a line number already existing in the project. We assign to the line characteristics such as class, diameter, pressures, etc. These data will appear in the final lines list. We draw the line starting from the filter and connecting to the pump inlet. Once drawn, this line has a flow sense and connecting information, which are shown on the command line. Through the tag line command, I can tag the line to show the main characteristics. Now let's connect the other lines. With continue line, we continue an existing line and connect it to the pump outlet. By doing so, we reuse the same line number. Now let's generate a new line to connect the tank to the line 9700. The nozzle is automatically generated. Let's go now to draw the last line, a refill line that will take the water to the storage tank. Assign the class, the diameter, and draw the line. Of course, this line has a flow that can also be inverted if necessary. In this case, we keep the default flow sense. The scheme is now complete. The stretch lines command lets you give the final touch to align the position of lines and components. Let's go now to tag the lines through the command tag line. With this command, we are going to place labels that are freely customizable by the user. Add a reducer, and with a double click, we modify the downstream diameter from 2 inches to 1 inch. Now, let's insert the valves. Pick the process line, and ESApro P&ID show me only the valves compatible with that class and that diameter. We choose a gate valve. The valve is automatically oriented and cuts the line, taking its characteristics from the class. We can see that it is a flanged or socket weld valve depending on the diameter. This is a flanged valve, as chosen in class. And here we have a socket weld valve instead. Now let's insert a valve on the water inlet line to the tank. In this case, we're going to insert a ball valve because our class includes also this option. After the threaded ball valve, we are now going to insert a reducer. We slightly arrange the scheme using the stretch line command. And now we're going to change the inlet line diameter. We increase the size from 1 inch to 2 inches. The valve is automatically updated from the class because for this size there was a flanged version. If I set the diameter 4 inches, I see that the software shows me an inconsistency. This valve is no longer in class. It will therefore be replaced. I delete the old valve and insert another compatible one. With the number components command, it's possible to assign to each object in the drawing a unique tag, which is the sum of the prefix already defined in class, with a sequential number that can be 2 or 3 digits. Once components are tagged, it's possible to locate them with the find command. If I select a tag, the component is highlighted. In the same way, it's possible to find a line by selecting a number. With the Generate Tables command, it's possible to generate AutoCAD tables that show the drawing data, a lines list, a valves list. In this case, we have a list showing the valves quantity. and a detailed table listing all the items with their different characteristics and their ubication. These lists are customizable by the user. We have a special table, which is the Symbols Legenda. Through the Project Options window, it's possible to choose how many descriptions must be shown into the lists. We can set the list to show 1 or 2 languages above the 5 available. Now let's get